Hi everyone, welcome back to Math 111. This is Scott. Let's get started. We're not going to be talking about section 3.6. Instead, we're just going to skip ahead to section 3.7. 3.6 is about the absolute value function, and we've covered everything we need to cover about that already. So 3.7. 3.7 is about the subject of inverse functions. So here's the idea. If a function f of x is 1-to-1, then there is an inverse function which we'll write f inverse of x that undoes f. Alright, so what does this mean? So there are a few ways of interpreting what this means. So different interpretations of inverses. One interpretation is, like I just said, it undoes a function. And what that means is the following. So first off, if f, and then you write it as like a -1, almost like an exponent, but you pronounce this f inverse. Is the inverse of f, then f composed with f inverse of x, they cancel each other out, they undo each other, and you just get x. And f inverse composed with f of x just cancels out and leaves you with x. So in other words, they cancel each other out. F and f inverse cancel each other out. So you can think of this as acting kind of like roots and powers. So a third root cancels a third power. A fifth root cancels a fifth power. So that's one meaning of functions and their inverses. Another meaning of functions and their inverses is this. So another way of thinking about it is the input of f becomes the output of f inverse and vice versa. So the input of f becomes the output of f inverse and vice versa. So in other words, what that also means is the domain and range also get switched. So the domain of f equals the range of f inverse, and similarly, the range of f is the same as the domain of f inverse. And then lastly, another twist on the same idea is that basically if you were to take the equation y equals f of x and switch x with y, then you'd get x equals f of y. Then solve for y, and what you get you'll get the formula for f inverse. Now we'll get into some examples of that, but first I want to make a note of a couple things. So note, all the stuff that we just said applies only to one-to-one functions. So a function has to be one-to-one to have an inverse. If a function is not one-to-one, for example, y equals x squared. So let's see, if a function is not one-to-one, and what that means, you recall, is that it fails the horizontal line test. So i.e., it fails the horizontal line test. So if a function is not one-to-one, and in other words, it fails the horizontal line test, then it doesn't have an inverse. In other words, it is not invertible. However, we might, quote, restrict its domain, which means cut out part of its domain, we might restrict its domain to make it invertible. An example of this, we all know that that if you see y equals x squared, it's going to graph as a parabola. And that is one of our classic toolkit functions, and most importantly about it for this, it is not one-to-one. It fails the horizontal line test. So this fails the horizontal line test. However, we can restrict the domain so that it passes it. Restrict the domain to x greater than or equal to 0. Now, what you'd have is only the right half of that parabola, and that would now pass the horizontal line test. So this is now one-to-one. And in fact, actually, this is one that you already know the inverse of. You know how to cancel a square. It's with a square root. But before we get to that, let's now look at some examples from the formula side of things. So the formula side of things is going to look like this. So here's an example. Find the formula for f inverse. And here we're going to start with some basic ones, and we're going to work our way up. So here's the process. So the process here, right, y equals f of x. Switch x and y around. Then solve for y. So this is the process that we'll be employing. And here, let's give it a try. So as an example, A. Let's say we have something relatively simple like f of x is equal to x minus 4. Okay, so this is just something to get us started. Nice simple case. So what you start with is y equals x minus 4, y equals f of x. But now we want to step through the looking glass, go into inverse land. X becomes y becomes x, domain becomes range, range becomes domain, horizontal becomes vertical, vertical becomes horizontal. And so what we get is x equals y minus 4. So that is step 1. Or step 1 was write it, step 2 is switch it, step 3 is solve it. So now we have a y that is no longer isolated, so we now just solve for it. Add 4 to both sides, and we'll have y equals x plus 4. And that is now the formula for the inverse. So f inverse of x is equal to x plus 4. Let's now take it a little bit further. Let's go f of x is equal to 5 minus x. So this is pretty much the same, but with the slight added complication of having a negative on the x. So y is equal to 5 minus x is what this means. This is the regular function and the regular x and y relationship, but we want to step through the looking glass, go to the inverse, which means x becomes y and y becomes x. So x equals 5 minus y, which now means that if I want to solve this for y, I have to get it by itself. The usual thing people do here is they subtract 5 and then divide by negative 1. Alternatively, you could add y and subtract x. They'll get you to the same place, so I'll just do what people are more used to, which is subtracting 5 from both sides. And then divide by negative 1. Now, the thing to remember about dividing by negative 1 is that it's going to distribute to both of these. And so that gives you that y is equal to negative x and then plus 5. So the negative distributes to both of these terms, and so you're going to have this, which means then that the inverse function is going to be, f inverse of x is going to equal negative x plus 5, or as it might more commonly be written, f inverse of x is equal to 5 minus x. Notice that in this case, the inverse function happened to be the exact same as the function we started with, but that wasn't the case here. Alright, now let's go to a more complicated category of function. So we'll go to a function that looks like this. So C. We're going to take f of x is equal to x over x minus 1. Alright, so the setup is still the same. You just go y equals, and then after you've written the formula, you do the old switcheroo. Y becomes x, and x becomes y. Now here, what we have to do is solve this for the y. But what makes it complicated is the fact that we have a y on the top and a y on the bottom. And so what that means is we are going to need to get the piece that's in the denominator out of the denominator. And so we'll multiply both sides by that and see what happens. Now when you multiply both sides of an equation by an expression like this, you have to be very cautious with your parentheses and make sure that you are correctly distributing everything that needs to be distributed. So this, the whole side, got multiplied by y minus 1, which should cancel that. And this whole side also got multiplied by y minus 1, which means it's going to distribute like that. And so here we're going to have xy minus x equals y. And let's remember what it is we're trying to do here. We're trying to solve for the y. So what that means is that we're going to want to get everything that has the y on one side, everything that doesn't have the y on the other. So I'll subtract y from both sides to move all the y's to the left. Then I'll add x to both sides to remove all non-y terms from that side. So if I do that, then what I'll have is xy minus y is equal to, so it's going to cancel that, that will cancel that, is going to equal x. Now here, when I have all the y's on the same side, the reason for doing that is so then I can factor it out and have just x minus 1 times y equals x. And when I've got it down to just one copy of y, I can solve this for the y by dividing by the thing that is next to the y. So here I divide by the x minus 1, and that'll cancel. I get x over x minus 1. In other words, f inverse of x equals x over x minus 1. Just like the original function again. So we'll take a look at what it actually means when functions and their inverses line up in this way. It's kind of a special case, but it does happen with some regularity. Alright, and then finally, the last example of a case like this, where we are going to up the difficulty one step more. We'll take something like f of x is equal to, and then maybe I'll have 5x minus 3 over 2x plus 1. So what we have here is a function that's got some pieces on the top and the bottom, and we are going to set it all up the same way. Y equals the formula for the function, so 5x minus 3 over 2x plus 1. And now, in order to solve this now we need to switch the x's and y's around. So x gets switched, and we have 5y minus 3 over 2y plus 1. And now we need to solve this for the y, and when we do that, we multiply both sides by the denominator of 2y plus 1. In order to cancel. And what that's going to give us is, on the right, no more denominator, just a 5y minus 3. And on the left, we're going to have 2y plus 1 times x, which means then the x is going to distribute, and we're going to have 2xy plus x is equal to 5y minus 3. And here, we're going to now have to move everything that has a y to one side, everything that doesn't have a y to the other. And when it comes to making decisions on this, my advice is look for whatever will make the most terms positive. So if I were to move all the y's to the left and all the x's to the right, then I'm going to be subtracting, and so I'm going to have a bunch of negative terms. If, on the other hand, I decide to move the non-y's to the right, and to the left, and the y's to the right, then I'm going to be adding, and I'll be subtracting. So it'll only end up with a little bit of negative. So that's what I'm going to do. I'm going to add 3 to both sides. I'm going to subtract 2xy from both sides. Again, not an important thing, but it is always a little bit helpful to do what you can to make sure that the most terms possible are going to be positive and not negative, just to make your own life easier. So it's going to be an x plus 3 on the left when all is said and done, and on the right it's going to be 5y minus 2xy. Now the reason why we did that, why we added and subtracted to both sides, was to get all the y's together. And the reason why we did that was to factor the y out from the right, so that we would have 5 minus 2x all times the y, so that to solve this for y, all I'd have to do is divide by the 5 minus 2x. Now that gives me x plus 3 on the top and 5 minus 2x on the bottom, which then tells me that the inverse function here is going to be f inverse of x is equal to x plus 3 over 5x, or 5 minus 2x. So that's how you actually find an inverse for a function. Now suppose that you had a function and you had what I told you was its inverse, and you wanted to check whether it was actually true or not. Or suppose you had just found an inverse and you wanted to be sure. So checking. Checking inverses. So the way to check an inverse, if somebody hands you one, is to just put in the composition of functions. So f of f inverse of x should equal x, and f inverse of f of x should equal x. So you need to just confirm that these are both true. So as an example, let's say that we had to confirm that, let's say, the following are inverses. And let's say the first example of a pair of functions that are supposed to be inverses are something like this. What if we have f of x is equal to x cubed minus 2, and g of x is equal to the cube root of x plus 2. Well, if these are really inverses of each other, then f of g of x should just cancel out and give me just x. So let's find out. So f is it takes its input, cubes it, and then minus 2. And then into there, I put the formula for g, which is cube root of x plus 2. Now, when I look at this, so that lines up with that. So when I look at this, I've got a cube on the outside, a cube root on the inside, so those do cancel each other out, and that gives me now just an x plus 2 minus 2. And those, in turn, cancel each other out, and that just gives me an x, which is what we're supposed to get. But then also, to check the other direction, I need g of f of x to equal x. So that means that the cube root of the input plus 2 should then, if I put in here the formula for f, should simplify down to just make x. Well, let's see. So we'll have x cubed minus 2, and now those parentheses aren't really doing anything, so I'll just write it again without them. Minus 2 plus 2, and you just work your way from the inside out, and you see that'll cancel with that, and you're going to have the cube root of x cubed, which is just going to equal x. And that also checks out the way it's supposed to. So f of g of x just canceled out to make x, and g of f of x just canceled out to make x, so that means they are inverses. Now let's try this again, and let's try it with something like this. So let's say f of x is equal to x plus 6 divided by negative 2. And let's say g of x is equal to negative 2x minus 6. Well, nothing is different about the setup here. You just start by saying f of g of x, and you put into the formula for f whatever you have there for the formula for g. So what am I doing? Minus 2. It's all minus 2. Let's just start that over. F of g of x is equal to whatever it is, plus 6, all divided by negative 2. What goes in here? It's going to be the formula for g, which is negative 2x minus 6. But these parentheses aren't actually really accomplishing anything, so what that's going to mean is negative 2x minus 6 plus 6 divided by negative 2. Now, here it's safest to just work our way from the inside out here. So we got negative 2x over negative 2, cancel the 6's. And now we have a negative 2 as a factor of both the top and the bottom. And so, sure enough, that's just going to cancel to make an x, which is what it's supposed to be if these really are inverses. Alright. Now, if you want to check whether a function is one-to-one, what you just need to do is produce a graph of it by any means, including just using Desmos. So we could use Desmos to graph. And then check to see if it passes the horizontal line test. So there'll be some problems in the book, and they'll ask you to do that, and then it is up to you to determine based on the way it looks in Desmos if it is actually a one-to-one function. In other words, if it is a function that you would be able to find the inverse of. Now let's think about what it means for inverses to switch the input and output of their function. So here, let's just take an example of a graph of a function, and it'll go like this. Let's say that the function that we're talking about is going to have a shape of just a straight line, and this is going to be 2, this is going to be 3, and we'll say this is the y-axis, this is the x-axis. Now let's say that this is f of x, right there. Now there are two sides to the function coin. There is evaluating and there is solving. So let's say that we wanted to just find, or in other words evaluate, f of 3. Well, that would be saying that 3 is the input, in other words the x, and it would be asking us to find the corresponding y. So here, that would be 0. But the other side of this coin asks you to do things like solve. F of x equals 2. Now here, this is now asking us to find the x value that'll make this work. So the 2 is the y, and it's up to us to find the corresponding x. Well, looking at the graph, when y equals 2, that means x has to equal 0. So x equals 0. Now, if we move to the inverse side of things, then we can be asking very similar questions, such as something like this. Find f inverse of 2. Now here, let's think about what it is we are being given, what it is we are being asked for. So ordinarily, what's inside the parentheses of a function is the x, which is the input. But in inverse land, input becomes output, output becomes input. So this is actually not the x anymore, but it's now the y, and it wants from us the x. Now the x value that goes with the y value of 2, as we just saw, was 0. So now basically the the shoe is on the other foot. What was once a 2 has become a 0. What was once a 0 has become a 2. Everything is switched in inverse land. Input becomes output, output becomes input, x becomes y, y becomes x, domain becomes range, range becomes domain, horizontal becomes vertical, vertical becomes horizontal. Everything is switched around. And then suppose we were trying to do something like this. Solve f inverse. F inverse of x is equal to, and then let's say 0. Now don't be fooled by the x that's in here. What we are actually talking about is finding what should go here to make this work. Now the inverse, so this x is actually just like a placeholder. It's not related to the xy plane. It's actually a little bit of an inconvenient fact about notation, that x is used sometimes as just generic input and sometimes as the x coordinate of the graph. Here, this is just a generic coordinate. So this is really the question that we want. Now from this original graph, it was f, and then the input would be x and the output would be y. But this has switched everything around, which means that the output is the x from the original graph, and then what it wants is the y. And so what that means is that we are looking for f inverse of what will correspond with an x value of 0. Well, an x value of 0 corresponds with a y value of 2. And so this is actually the same equation as this one, but just with the shoe being on the other apparent foot. So now again, it's a little bit confusing because this says solve this, which means our answer has to be of the form x equals, but this use of x is just a placeholder. It's a placeholder variable. Not the x coordinate. It's a little bit tricky, but it's because the equation that we were given involved an x. Now, ordinarily, I wouldn't have done something like this, except that is what your book does, and so I wanted to prepare you for that. Now, one last thing here: the relationship of the graphs of functions and their inverses. So, sketching. Graphs of inverses. So if we have a graph of a function, we can sketch its inverse by switching the x and y. So switch x with y to get the inverse. Now, this can be done in a couple different ways. Sometimes the easiest way is to just reflect the graph about the line y equals x. So your friend, the identity function from the toolkit. So you can, so that's one way of doing it. Another way is just to straight up change the x and y coordinates of every point and see what you get. Now, when you do this, the domain and range are flipped. I should say switched. So the domain of f becomes the range of f inverse and vice versa. So as an example, let's take a graph like this. Let's say that we have a graph of f and it looks like the following. So let's say that this is an x value of 3. Let's say that this is an x value of, let's say 9. Let's say over here what we've got is a y value of 0 up to a y value of, let's say that that is equal to 8. And this is a graph of f. Now, if we want to sketch, so that's going to be part A, sketch f inverse, then what that basically means is you take the line y equals x, and you are going to just, reflect the graph about that line. There's nothing wrong with that. Just my cross looked like it was my underline looked like it was crossing it out. And so for the purposes of the notes, I just want it to be clear. These are the instructions. So sketch f inverse. Well, now what you do, you can just draw that little diagonal line, y equals x. And basically, you just take everything and move it to the other side of that line. All the x-coordinates become the y-coordinates, all the y-coordinates become the x-coordinates. So what used to be an x of 3 becomes a y of 3. What used to be an x of 9 becomes a y of 9. What used to be a y of 0 becomes an x of 0. What used to be a y of 8 becomes an x of 8. And now here, so here we got an x value that goes from 0 to 8, as the y value goes from 3 to 9. So you look at this, you look at that, and basically if you were to put them together on the same graph, they should just be a mirror image of one another about the line y equals x. So all the x-coordinates become all the y-coordinates, all the y-coordinates become all the x-coordinates, and the way this one is kind of leveling off in a horizontal direction means that this one should be going in a more vertical direction as it proceeds. The way this one starts off being kind of vertical means that this one should start off being kind of horizontal. Everything about the inverse switches. X becomes y, y becomes x, domain becomes range, range becomes domain. Anything that is horizontal becomes vertical, and vice versa. And then B, find the domain and range of f inverse. So the domain of the original function f and the range of the original function f are both visible to us. And so as a result, we can just make a little grid here where the domain of the original function f goes from 3 to 9, and the range of the original function f goes from 0 to 8. Now in the inverse case, these just switch and these just switch. So this now becomes 0 to 8. And this now becomes just 3 to 9. Domain becomes range, range becomes domain, horizontal becomes vertical, vertical becomes horizontal, x becomes y, y becomes x. And that's how the graph goes. And then the last little bit, this is now a slight twist, is in the subject of applications. So when it comes to application problems, in other words, word problems, there's a slight change in the way we usually think about it. So we don't usually switch the letters that are used in a real world function. What we do instead is we just change the input and output roles that they play. As an example, we might say something like the formula that converts between inches and centimeters. So inches and centimeters. So a way that this might be expressed is something like this. I of C, meaning I is the inches, C is the centimeters. So here centimeters is the input, I is the output. I of C is equal to 2.54 C. Meaning that if you give me a length in centimeters, I would multiply it by 2.54, and that would give me the length in inches. Now, then the inverse function would be, so if I write it like I equals 2.54 C, I would just solve this now for the C and get C as a function of I. So then C would equal I divided by 2.54. And so then that means the inverse function here, C of I, is equal to I divided by 2.54. So here, what we had was an input of centimeters and an output of inches. And down here, what we have is now the reverse, which is an input of inches and an output of centimeters. And what we did was solve this for the C. So we don't just do like we did generically with x's and y's of just switching their roles and solving for the other one, or sorry, switching the letters and solving for the other one. We just actually switch their roles so that whatever was once the input becomes now the output and vice versa. All right, well, that's going to do it for section 3.7. So I'll see you next time for the next episode of Math 111. Bye.